Okay, here's the key for the area between two curves assignment. And in fact, for the first problem, we only have one curve, so we don't have to look between two curves here. We just have to find the area of the region between x squared plus 4, negative x squared plus 4x and the x-axis. So we're looking for that shaded region right there. We're looking for the area of that. And the area is going to be equal to the integral from our left end, which is 0, to our right end, so 0 to 4. Of our function, which is the opposite of x squared plus 4x dx. Okay, so fundamental theorem of calculus, we need to take the antiderivative, so that's the opposite of x cubed over 3, plus the antiderivative of 4x, which is 2x squared, and that's being evaluated from 0 to 4. We're going to plug 4 in first, so we have negative 64, 4 cubed is 64 thirds, plus 4 squared is 16, doubled is 32. That's what happens when we plug in 4. Now we're going to plug in 0. When we plug in 0, we get 0. So this answer is good right here. If you're looking to simplify it, well, 32 is, so we're going to multiply that by 3, so that's 96. So that's negative 64 thirds plus 96 thirds, which is 32 thirds. Or, which is the same thing if you like mixed numbers, as 10 and 2/3 overall. So all these answers are good. Okay. Problem number 2. Now we have two curves. We're looking for the area of the region between those two curves. So it's that little banana right there. So we need to find our bounds. And it looks like our bounds are 0 and 1, but let's verify that. We find the bounds by setting the two functions equal to each other. X squared is equal to x cubed. So if we subtract x squared from both sides, then we have x cubed minus x squared is equal to 0. 0 is what we're looking for. We're trying to solve an equation. So now we can factor out the common term, which is x squared, leaving us with x minus 1 is equal to 0. And then we can cover them up one at a time. And we see if we cover up the second one, x squared is equal to 0, so x must be 0. And if we cover up the first one, x minus 1 is equal to 0, so x is equal to 1. So that verifies that our bounds are 0 and 1. So that's what we have here, the integral from 0 to 1. Next question is, which curve goes first? Right? Well, we can see that the x cubed curve is this one right here, and it actually dipped below x squared. X cubed is our bottom curve, and x squared is our top curve. However, we can verify this by picking a number between 0 and 1. So if we pick a half, right, a half cubed is a half times a half times a half, which is 1/8. And a half squared, if we plug that into the other function, it's just a quarter. And a quarter is bigger than an eighth. So again, we can see that x squared is the larger of the two curves in our region, and therefore it should go first. X cubed will go second, and the whole thing needs a dx. Now we do our fundamental theorem of calculus. X squared turns into x cubed over 3. X cubed turns into x to the 4th over 4, being evaluated from our two best friends, 0 to 1. When we plug in 1, we have 1 cubed over 3 minus 1 cubed over 4. When we plug in 0, we get 0. So we're looking at a third minus a quarter, which is fine. If you want to get a common denominator, that'd be 4/12 minus 3/12. So we also could look at this as 1/12. And now if we move to our final problem, we have 2x minus x squared and the opposite of x. Okay, so we know that one of our bounds is going to be 0. We can see that they intersect at the origin. But let's find the other bound. We have 2x minus x squared equal to the opposite of x. So if we add x to both sides, we have 3x minus x squared is equal to 0. We can factor out an x, leaving us with 3 minus x being equal to 0. So that holds true that x can be 0, and also x could be 3. All right, there's our two bounds, the integral from 0 to 3. Our parabola is our top curve, so that's 2x minus x squared going first. And we're going to subtract the opposite of x, and this whole thing gets a dx, which means we technically need brackets right there. Okay, so now let's combine these just to make the anti-deriving a little bit easier. This is really the minus the opposite is plus x, so 2x plus x is 3x. We have 3x minus x squared All right, and 3x's antiderivative will be 3x squared over 2. X squared's derivative will be x cubed over 3. That's being evaluated from 0 to 3. We plug in 3 first. We have 3 times 3 squared, or 27 over 2, minus, and then 3 cubed is 27 over 3. If we plug in 0, we get 0. We love that 0. So again, we're done right there. However, if we put this all over 6, well, that means that we have, so we'd have to multiply that by 3. So 27 times 3 is 81. So 81/6 minus, we multiply that by 2, so that'll be 54/6, which means we have 27 over 6 as our final answer, which would in fact simplify if we divide by 3 to 9/2.